use the graph to draw the inverse. Now, in order to graph the inverse, we just have to reflect this function by the line y equal to x. And y equal to x is just the line that cuts through the origin diagonally. And there's actually a formula for this. So each coordinate, to reflect it across this line, we just interchange the y and the x values. So xy is going to become yx. And here's what I mean. So here I have three main points. I have 4, 2, -1, 0, and -3, -2. So the points that I need to reflect are going to be, well, let's begin with 4, 2. That's going to reflect to 2, 4. Then -1, 0 is going to reflect into 0, -1. And then -3, -2 is going to reflect onto -2, -3. So let's go ahead and plot these points. So 2, +4. Beginning at the origin, I'm going to move 2 units to the right, and I'm going to go up 4 units. So 1, 2, 3, and 4. And now I'm going to graph or plot 0, -1. So beginning at the origin, I'm going to go down 1 unit. That's my second coordinate. And now I'm going to plot -2, -3. Beginning at the origin, I'm going to go 2 units to the left, and I'm going to go down 3 units. 1, 2, and 3. So I get the inverse graph. So that one is f inverse. So I'm going to put that -1 in there. Graph the inverse of f of x equal to x squared minus 1 if x is greater than or equal to 0. Now notice that this function, if we apply the horizontal line test, so let me go ahead and grab this line here. And if we begin to just place it somewhere on the graph, we can see that it fails the horizontal line test at many locations. So here we can see that there's 2 points that lie on this horizontal line. That's where this part becomes very important. X greater than or equal to 0. Because if we restrict this function, so let me get rid of this. If we restrict this function to only the values where x is greater than or equal to 0, now this part, just this green part, we can get the inverse of that. And here's how we're going to do it. I will begin by establishing 3 points on this part where my function is greater than or equal to 0. Because here, the horizontal line test, well, we passed the horizontal line test. So the points that I'm going to pick are going to be at 1, 0, 2, 3, and 3, 8. And then I'm going to use these as reference points to give a decent sketch of what the function is going to look like. Now, in order to get the inverse, I'm just going to reflect these points over the line y equal to x. And the reflection over this line just has me switching the values. So the first point that I'm going to reflect is this one. So now I'm going to plot the point 0, 1. Here I'm going to switch them, and the second point I have to plot is 3, 2. And then my last point, once I switch the order, I'm going to have 8, 3. So plotting 0, 1, I'm going to begin at the origin and go up to 1. Next, to plot 3, 2, I'm going to begin at the origin, go 3 units to the right, 1, 2, 3, and go up 2 units, 1, 2. And then the last point here that I'm going to reflect is 8, 3. So beginning at the origin, I'm going to go 8 units to the right, so 6, 7, 8, and then 3 units up, 1, 2, 3. We're going to go ahead and plot that point right there. And now I have a sketch of f inverse.